Alright guys, welcome to section 6.5. Today we're just going to do trapezoids. Tomorrow we will do kites. First thing I want to point out on trapezoid. We know that a trapezoid has one set of parallel sides, so I know the two bases are parallel to each other. Now, I know that you always think that this link, or the bottom, is the base, but a trapezoid has two bases, the top and the bottom, not the diagonal sides, but the sides that are parallel are both considered bases. Now, that means that we have two sets of base angles. This is a set of base angles, and this is a set of base angles. And then, just like in an isosceles trapezoid, or an isosceles triangle, this is a leg, and this is a leg. Okay, now my base angles are defined as two angles that share a base. Now, they are not two angles that share a side. It has to be a base, so it has to be one of the two sides that are parallel to each other. Okay, properties of a trapezoid is we have exactly one set of parallel sides. The other thing that we have is a midsegment. Now, we had a midsegment when we were talking about isosceles triangle. It's the same thing in an isosceles trapezoid. So, if I were making a trapezoid, let's do a line here. Like so. If I were making a trapezoid. Now, my mid-segment is going to connect my two midpoints. So let's make a midpoint, I don't know, there-ish and there-ish. Now if I connect that line, or connect my midpoints, I should have a line that's directly between my two bases. Now we're going to label our bases. This is going to be base 1, this is going to be base 2, and then we'll just call the length of this x. Now my mid-segment joins the midpoints of two non-parallel sides. Okay, now we have some properties for our mid-segment. So the first property is that a mid-segment is parallel to the two bases. So that means that this line is parallel to this line, which is parallel to this line. The other thing we want to know is the length of a midsegment is 1/2 the sum of the bases. So if I were going to put that into a formula, then I would say x equals 1/2 of base 1 plus base 2. And that is the value of this line here. Okay, now moving on to some examples. Our first example is this trapezoid here. So we know that this is our midsegment because if this line is congruent to this line, then this point here has to be my midpoint, and same goes for this side. So to find x, my formula again is x equals 1/2 base 1 plus base 2. Now, I can arbitrarily pick which one is base 1 and base 2. It does not matter. I'm just going to say that one's base 1 and base 2. So I have x equals 1/2 of 8 plus 24. So then I have 1/2, 8 plus 24 is 32. So x is going to equal 16. Okay, next problem. We are going to do the same thing here to solve for x, it's just going to be a little bit more complicated. So we have x, which is our midline or our mid segment, is equal to 1/2 our base 1 plus base 2. So we're going to label this as our x, this is our base 1, and this is our base 2. Now I'm just going to plug that into my formula. So I have 6x minus 5 divided by 2 equals 1/2 times 2x plus 3 plus 3x plus 5. Now I put this in parentheses because my 1/2 is being multiplied by this whole thing. So now I have 6x minus 5 divided by 2 is equal to 1/2 times, combine like terms, I have 2x and 3x, which is 5x, and 3 and 5, which is 8. Now, I want to get rid of this 2 over here, so I'm going to multiply both sides, the whole thing, by 2. And when I do that, 1/2 times 2 is just 1, so I'm going to be able to get rid of this 1/2. So now I have 6x minus 5 is equal to 5x plus 8. And I can subtract 5x just like a normal equation. Then I have x minus 5 equals 8. Add 5 to both sides. So I have x is equal to 13. Now, I could also find my lengths of all these sides by plugging in my x equals 13 into these equations. And the next example. Now, the next example has our x as one of our bases. So this is normally our x, or our mid-segment. This is our base 1, and this is our base 2 in our formula. So we have x equals 1/2 base 1 plus base 2. So we have our x, which is 14, our x in our formula, not x as a value. 14 equals 1/2 times x plus 15. Now if I multiply this whole side by 2, then I get rid of this 1/2. So I'm going to multiply both sides by 2. So then I have 28 is equal to x plus 15. Then I'm going to minus 15 on both sides. So I get 13 is equal to x. Now that means that this value up here is 13. Okay, now we're moving on to the isosceles trapezoid. Now again, an isosceles trapezoid has all the properties of a trapezoid. So that means I know that this side is parallel to this side. Then an isosceles trapezoid, I know that the non-parallel sides are congruent. Non-parallel sides are congruent. Now, our next property is going to be that our base angles are congruent. Now, you remember from the first picture, from the first slide, our base angles are these angles and these ones over here. So back to our thing. So that means our base angles are congruent, which means this one is congruent to this one. And then this angle here is congruent to this angle here. And our last property is that our diagonals are congruent. Just like a rectangle, our diagonals of our trapezoid are going to be congruent. So I have a diagonal here and a diagonal here. And they don't bisect each other, keep that in mind. They are just congruent. Okay, moving on to our final examples. We are going to find the missing values of our trapezoid. Now, if you want to, pause the video and try to do it yourself first and then check your answers when I do it, or you can follow along and do that with some other ones. So, I know that my base angles are congruent, so that means 34 degrees is equal to angle x. So here is 34 degrees. Now, I also know that since these two are congruent and these two are congruent, and the whole trapezoid is 360 degrees, that this angle here has to be added with this one to be 180 degrees. So I can figure out what z is by doing 34 plus z is equal to 180. Then I just minus 34 from both sides. So I get z is equal to 146 degrees. Now, I know that z is 146, and my base angles are congruent, so that means y has to be 146 degrees as well. So now let's do it again. I know that this one is 103 and my base angles are equivalent. So that means my r is equal to 103 degrees. I also know that r plus q, or 103 plus p, is equal to 180. So I can do 103 plus p is equal to 180 degrees. Then I minus 103 from both sides. So I get P is equal to 77 degrees. So then I know P is 77, which means that Q also has to be 77 degrees. And our last example. Our last example says that BR is x plus 1. So this diagonal right here is x plus 1, this whole thing, in blue. The other thing I know is that AK, so the red one, is equal to 2x minus 3. Now, back here, one of my properties for an isosceles trapezoid is that my diagonals are congruent. So that means that I can say that x plus 1 is equal to 2x minus 3. So I subtract 1 from both sides. So then I have x equals 2x minus 4. Then I minus 2x from both sides. So I have positive x minus 2x, which is going to make that negative x equals negative 4. Then I can divide by negative 1 on both sides. So I get x equals positive 4. Now I could go back and figure out what my diagonal is by saying 2 times 4 minus 3 is equal to AK, and 2 times 4 is 8, minus 3 is 5, so 5 is equal to my diagonal AK, and since AK is congruent to BR, then BR is also 5. Alright, have a good night.